Hello everybody, welcome to our channel. In today's video, we will be discussing about behavioral design pattern and one of its kind. Observer design pattern is heavily used in real-world examples such as user interface frameworks, event listeners in GUI frameworks, and publisher-subscriber systems such as YouTube subscription notification system. Understanding observer design pattern is very important if you are a Java developer and working as a backend development and doing event processing. Event processing is the most important topic in Spring Boot development when you want to achieve coupling between two application modules. So let's go ahead and start with understanding the concepts and theory behind the observer design pattern. First of all, we'll start with defining a diagram where we'll be describing each and every components of the observer design pattern. First of all, an observer design pattern consists of an observer, right? Let's define our observer, which would be an interface, right? And it would have a simple contract called void handle. The void handle will monitor something called as property change argument, property change event. What this observer class does is basically checks for any events change, and its concrete implementation will provide us with whatever business logic we need to process whenever this particular property change events occur. So let's define our second class called property change argument. Let's copy paste this value, and this would be a generic type called property change class, and it would have arguments, simple arguments such as type source. Basically this will be the source object. Then there would be property name, in this example we are trying to understand with the help of a property change event. So the property change would be a simple class with source as t, generic type t, property name as string value, and new value as an object, signifying that if a new value for particular source is occur for a given property, then this event would be used to act as implementation and will check all the observers and then do the processing. Okay, so we are clear with this property change event, right? Now let's move ahead to another important class, which is called as observables. Observables basically means a subject, the subject on which we are listening to, or subject on which all the observers are listed. So basically observable will be having or maintaining the list of observers like this, which we might call it as listeners or observers. Let me call it as a listeners over here. Then it will have additional two simple methods called as subscribe, right, which will take in an observer obviously to add it to the list of the observer listeners, correct? So the subscribe method will basically add the new observer to the list of listeners, which we defined just above. And there would be another method. Additionally, we can add an unsubscribe method also, which would use the dot remove method from the list collection, but let's not add it right now. We'll head it towards the most important property void method called as property change. And this particular method will be named as property change. Basically this would monitor for any property change trigger. Once this property change triggered from the concrete observable class or the concrete subject class, which I will try to explain in the next few minutes, it will take in some arguments and loop through. It will loop through all the listeners, right? It will loop through all the listeners and trigger the void handle method, right? For now understand that the observable class maintains a list of observers or listeners with the help of void subscribe and void unsubscribe method. Let me add a void unsubscribe method. 1 minute. subscribe. So this will add the particular subscribe method, unsubscriber will remove. Then we have a property change method, which would basically iterate through all the elements of the listener list, the list of observer, and issue the handle method, right? And this property change method will be triggered by a concrete class called concrete observable. Concrete observable. The name is not it's a very big name. The class name concrete observable is a very big name. Yeah, so this would be the concrete observable. Let's name it something which is more realistic. Let's name it as a person T. And the person T class would basically be extending, or basically be doing inheritance towards this, extending to this class. Let me give an arrow, better understand. So this will extend the parent class, extend this observable class, right? And the person class will have simple properties, like starting with, it would have a string name, then it would have an integer age, right? What basically we will be monitoring or monitoring with this particular design pattern is that whenever a person's age changes, right, whenever person's behavior changes, the age changes, we want to notify this behavioral change to our system. And how can we achieve is that, firstly, the person class is a concrete implementation of observable, so it has an access to all the subscribe, unsubscribe, void methods, right? Great. Now what we will do is, within the set age method, we will take in the new age and provide an implementation as such that when this set age, when the age changes, we will trigger the property change, right? The property change method by passing in the t string and the new value called object, correct? That is what we will implement. Further ahead, this will trigger property change, and this property change will basically trigger the handle method, right, by passing in the property change event. That is done, but we are missing one thing. We don't have the implementation of this handle method. We need to have a concrete observer also, right? So in this case would be our client application. So let me define a client application with a rectangle. This will be a client app which will be implementing, let's draw, this is drawable, yeah, make it dash dash dash. This basically is implementing this application called observer, and it will provide an override version of public void handle by taking in the property change argument. Basically, let's put it accepts property change event, sorry, and this will be our basic implementation of an observer design pattern. The client tab will do what? Further ahead, it will create an instance of this person class. So it will have a person over here, right? And the person will say, okay, I am going to change my property, I'm going to change my age. So the person will trigger set age method, right? The set age method will trigger the property change method, and the property change method will loop through all the observers or the listeners, and whoever is listening or whoever is concretely implemented this observer class, whoever is subscribed to this particular listener, so that subscription part will be done over here, person dot subscribe this, and this would be the concrete implementation of client app. So with this, what will happen is, it will trigger the overrided implementation of client application, thus signifying okay to our whole application. And so and similarly, there can be multiple client application. For example, in this case, it would have been a email app, email sending app, or email sending module. There could have been one more. There could have been one more, like create user module, right? And this user module will also be part of, so there will be user module, and this user module will be having its own concrete implementation, no doubt. And but the user module should be injected to this one of the main apps. So let's call it the main app. There would be one more called, let's say, email sending module. So both these email sending module, right, this should be added to add it as a subscriber. Once all this are added to the subscription list, it would then be automatically aware, okay, this particular event has occurred. So basically this would be again subscribing. Oh yeah, subscribe. Again there would be a subscribe. So this is how multiple listeners will be aware when a particular subject or concrete subject, which is our person class, changes. I hope this is clear. Now we'll start with the coding, and in this coding we won't do the coding for these two part. We'll just take care of observable, observer, observable, a concrete observer, and a property change event, right? Remember guys, this is very useful when you do event processing in Spring Boot. So if you are working with a Spring application, this would be a very good lecture for your improving your understanding. Let me rename this to call it as an event processing in Spring Boot. Also there are some drawbacks with this particular design pattern, so more refined observable design patterns were also introduced, but knowing this will also be enough for now. In future videos we will discuss the different drawbacks of this particular design patterns and how do we overcome it with the help of event based observer design pattern, then publisher subscription based design pattern, which is heavily used in stream processing, right, reactive stream processing. So all those are advanced level topic. Let's now focus on this place. So I will open up my IntelliJ IDE and let's create a package called YouTube. I will define a package called observer pattern, observer. Let's add a interface for, let's observer, right? This observer will be of a generic type, and it will have only one contract called on handle. On handle will take in something called as property change event. So in this example we are trying to study the property change event. So whenever any property changes, event argument of type T, and this will be TRs or suggestion marks. Let's create this class. Remember from the diagram we know this property change event consists of a source object and the property name which it is going to change, and the new value, whatever the new value. So let's define private source T source, generic type T source. Then we have private string property name, and we have private object called new value, right? Now let's define the constructor to be a simple constructor with 3 values, right? That's it. We are okay and ready with our property changed event. Then we have a void handle method. Okay. This observer pattern is the observer class is ready. Now let's go ahead and create observables. Observable class. This basically will be generic type T, and it it will maintain a list of observer, generic type, right? Put this array list. So now we somehow want to maintain this list of observers. So let's create a void method called subscribe. Subscribe will take in an observer as an input and add it to our let's create an unsubscribe method that will remove, and let us create on property handle property change, on property changed. It will take in t source, then string name, property name, then object of new value. Don't have an old value, we don't have support for old value, but still the auto suggestion is suggesting that. We'll ignore that auto suggest, right? We'll try to implement it. So okay, so this is the most important on property changed method. What basically we'll do with this method is whenever any property change is triggered from the concrete class, right, that particular on property change we do for go through each iterate through all the observer list of observer and trigger on handle method, which is we have defined in the interface, and this would take in a new property change argument with a source property name and the new value that we will be obtaining from the concrete class. So now let's go ahead and create a concrete class. In this context we will be talking about a person class, right? Person of, and this will extend observable of type T, shift T, person T, and the person, and this concrete implementation of the observable class called person will have two properties. Let's keep it simple, string name and string age, int age, sorry. Then it will have a constructor, simple constructor, and then it will have set a method. So let's generate set a method for age. So whenever this age will change, so let's say we'll check an if condition. If the age that is passed as an argument is equals to this dot age, then we'll simply return there is no change in the age, right? But if this age got changed, then because are we implementing, what we are going to do is we will say on property change handle, the source will pass this as this age and the age, correct? This will be a trigger point. So whenever the persons or the subjects property changes, will trigger on property change method that would be sent to our observable, and observable will loop through all the registered or subscribed observer, and if it finds any observer it will trigger on handle, right? So now the only piece of the puzzle is we need to add a new class, a client app. Let's suppose we call it as client app, which would also be an implementing observable, because we want to provide implementation, right? Sysprint will be simple, persons, this argument dot, let's modify this class to hold it all as public, otherwise we need to have access methods. So make it simple. So we have the property name, then the person's age changed to a new age of argument dot new value, right? This is the concrete implementation of client app. Now what does a client app need to do is a client app need to hold a reference to a person. So let's create a new person, and the person name would be, let's say, Max, and it has a age of 50. Okay. And first of all, the person needs to subscribe. Person to subscribe. Okay. Okay, I am a person, but I want to subscribe uh, this client application to this. So, but this is giving an error, so it is not. Client tablets cannot be referenced from a static context. Make main non-static. Okay, I'll be back in a minute. Okay. So we are building the concrete implementation of observable class. Okay, going back to IntelliJ. Here we got some error, right? That's because we in a static context. Let's create a public void called client app, and this would simply create a person object at this reference. And what are we gonna do to mock the property change? Okay, let's add a for loop, right? It will trigger a for loop for 10 times. It will iterate through from 0 to 10, and for each instance, what are we going to do is we want person dot set age to currently what is the age of this person. It is person dot, there's no getter, right? So let's define a getter for this method. Generate getter age get age plus I. So what basically we are trying to demonstrate here is we will be triggering the set age events. Internally the set age will trigger the on property change event, and this on property change event will loop through each subscriber. The property change event, where is the property change? This property change event will do one handle for each observers. So currently we have only one observer, which is this, right? Multiple observers we can have. For example, let's suppose we have another subscriber or another class, call it as class email sending observer, and this will have its own implementation. Implements, what does it implement? Says okay, serves out sending email, send email sent to person, sending email, sending age changed email notification. Suppose so we have subscribed this person client app to the list of observable concrete. We want to also subscribe the email sending. So what I can do is can have a person dot subscribe another. Now this would be new email sending option, right? So now we have two subscribers. So for each subscription it will loop through the observable class and send out the concrete implemented messages process. Let's test this out. For that, let me invoke the client app here. Client app. This should be static of public void. Okay guys, so we needed to add a client app, so let's add it there and run it in the main method. Can you see this? So when we were setting, we just set the property change where we just set the change age of this person, right? When the age is set, it in turn the observer behavior design pattern will notify its observers, which in case is a client application, an email sending application, that okay, see now the age has changed, please send an email notification 17 18 for each change event. It is sending or doing some task such as notifying or email sending task to the application. So each observer is aware of the property changing in this particular line, and based on that rest of the applications are set into the motion. So this is how observable result pattern is useful. It is heavily used in event processing. So in my next video I will try to explain you what does an event processing mean. So with this learning, it will become very easy for you to understand what an event processing is in Spring Boot, and we'll also try to understand with a real world example where we will imagine a user registration system. So thank you for watching this video till now. If you like the video or understood all the topics, please subscribe to the channel. We will be coming up with more such learning concepts and tutorials. Thank you for your time. Have a nice day.